This presentation is about scatterplots and being able to draw a line of best fit to describe the correlation using scatterplots. A scatterplot is just what it sounds like. It's a scattering of plotted data points. So you take your ordered pairs that describe something. So in this case, it's the number of days of training that elementary school students had compared to the number of push-ups they could do. And you plot the ordered pairs. So I plotted the first ones for you. So the next one is 10, 8. So you go over 10 up to 8 and you plot your point. 12, 8. So over to 12 up to 8. And 13, 9. So now all of the ordered pairs are plotted and you have your scatter plot. We can then use the scatter plot to draw a line of best fit. The line of best fit or best fit line of the set of data is just the linear equation that best fits the pattern of the ordered pairs. When you're drawing your best fit line, you're trying to get a line that best represents the data. So you're trying to find a line that has about the same number of data points above as below. After you have your line drawn, you can find the equation using 2 points. The 2 points that you use do not have to be part of the original data set, but they could be. For example, on my line, it passes through this point exactly, and I'm going to use this point. So my 2 ordered pairs would be 3, 3 and 10, 7. From here, we need to review how to find the equation from 2 points. First, you need to find the slope, change in y over the change in x. So that gives us 4/6 or 2/3. I'm going to use the point slope form. So y minus 3 equals 2/3 times x minus 3. Use the distributive property to get rid of those parentheses. So 2/3 x minus 2. And then add 3 to both sides to get y by itself. So the line of best fit has the equation y equals 2/3 x plus 1. That's my best fit line. What scatter plots are used for most often is determining if there is a correlation or a relationship between the variables. For example, we could look to see if there is a relationship between the number of hours that you studied and your test scores, or the size of your hand compared to the size of your foot. If there is a relationship between events, this is called correlation. So we could have a high positive correlation. A high positive correlation has a line that has an upward slope. So you can see the pattern is going upward. So positive slope, positive correlation. And they're very close together. All of these plotted points are very close together. So it's a high positive correlation. Unlike this one. Here we can still see that there's a positive slope, but our plotted points are not close together. They're spread out more. So the closer they are together, the higher the correlation. The further they're spread apart, the lower the correlation. So this would be an example of a high negative correlation because the slope is negative, and a low negative because it's still going down, sloping down, but the points are further apart. You could also have no correlation at all if you had a graph and your points were just all over the place with no pattern at all. That would be a no correlation. We have to be careful though with scatter plots. Just because there is a correlation, there might be a relationship between 2 variables. It doesn't mean that one causes the other. It doesn't mean there's a cause and effect relationship. For example, this is a graph showing the number of jars of jam that were sold at the Pick and Save compared to the number of CDs sold in Wisconsin. And we can see that there is a strong positive correlation or a high positive correlation, but clearly the number of jars of jam that were sold really has nothing to do with the number of CDs sold. So one does not cause the other. So just because there is a correlation, it doesn't mean that there is a causation. Sometimes it does, but sometimes it does not.